This video is going to be covering problems 1, 2, and 3 from the Mod 4 Practice Quiz 2B. So let's solve these problems. In problem number 1, you're supposed to simplify the rational expression. The first thing you want to do in any problem like this is factor anything that is factorable. So this third denominator can be factored into x minus 2 and x minus 1. The reason why we do that is we can now determine what is missing from each additional fraction. In fraction 1, you are missing a factor of x minus 1, so I have to multiply top and bottom of the fraction by that. In fraction 2, you're missing x minus 2, so I need to multiply top and bottom of the fraction by that. Since the third fraction already has both factors, I don't need to multiply the third fraction by anything. So in the first fraction, I have parentheses of x minus 1 and x minus 5 in the numerator. In the second fraction, I have a 3x and an x minus 2. And then in the third fraction, I have a numerator of negative 6x. That all goes over the common denominator that we created, which was x minus 2 and x minus 1. From there, we've got some distributive property, foiling, etc. to do. So if I FOIL out my orange parentheses, we've got terms of x squared minus x minus 5x plus 5. If I distribute my green 3x, I have a 3x squared and a negative 6x. And then I have my negative 6x still on the end. All over my common denominator, x minus 2 and x minus 1. The last step of the problem would be to combine my like terms. So we want to write the numerator in standard form, so we'll start with our x squareds. If I add the orange x squared and the green 3x squared, we have a result of 4x squared. If I add up my x's, I've got a orange negative x, an orange negative 5x, a green negative 6x, and a blue negative 6x. All of those together are going to give me negative 18x. And then the only constant on the top is a plus 5. The denominator, x minus 2 and x minus 1. So my final answer should look like that. Moving on to the next problem. The next problem is multiplying and dividing a series of fractions together. So anytime we do that, we are going to first factor everything that is factorable. So when we talk about my first numerator, if I do my AC factoring, I would look at x squared minus 3x plus 2. Factoring that is going to give me x minus 2 and x minus 1, but we will have to remember to put the 2 back in. If I divide the 2 out of the first parenthesis, we get factors of x minus 1 and 2x minus 1. In that denominator, x minus 1 or x squared minus 1 is a difference of squares, so we have x minus 1 and x plus 1. Go to fraction number 2. The only thing you can do in the numerator is factor out an x that's in common. In the denominator, you can't factor anything, so it remains 3x plus 4. We go to the last fraction. If I factor, the x squared minus 9 is a difference of squares, so x plus 3x minus 3. And in the denominator, the only thing I can do is take out an x that is in common, so x times 3x plus 4. So again, the first step there, just factor everything that is factorable. Next thing I'm going to do is change that last fraction. Instead of division, we're going to change it into multiply by the reciprocal. Since the last fraction is the only thing being divided, I'm going to leave the first two fractions completely alone because they do not need to be changed at all. So I'm looking for common factors. I have factors of x minus 1, top and bottom. I have factors of 3x plus 4, top and bottom. I have factors of x minus 3, top and bottom. Those are the only common factors that are top and bottom. So what's left over? I've got a 2x minus 1, an x, and an x. So that means I have x squared and 2x minus 1. On the bottom, I've got an x plus 1 and an x plus 3. So in the denominator, I have x plus 1 times x plus 3. And that is the solution for the second problem. Now we move on to number 3, which is a complex fraction. The only way to simplify a complex fraction is to first make sure the numerator and denominator are a single fraction. So the numerator, that's already done. We're not going to do anything with the numerator currently. The denominator is what we're going to need to fix. The first fraction in the denominator is missing an x plus 5, so that's what we're going to multiply by. And the second fraction is missing the singular x, so that's what we're going to multiply by. So in the denominator, I have a 3x plus 15 plus 4x all over x times x plus 5. That means I've got a 3x over x plus 5 in the numerator, and I have a 7x plus 15 over x times x plus 5 in the denominator. Now remembering what this overall fraction means, it means division. So I can rewrite this as multiplied by the reciprocal. So the numerator fraction stays the same. The denominator fraction flips upside down when we rewrite the problem as multiplication. We're going to cross-cancel anything that cross-cancels, so the x plus 5s go away. On the top, you're left with a 3x and an x, so 3x squared. And on the bottom, you're left with a 7x plus 15. And that is your solution for the third problem.